Hi, we're on page 3 now. Here's a numerical and variable exercise, cube root. So if I take a close look at the number 40, and I'm trying to find any buried perfect cube, 40 divided by 2 is 20, not a perfect cube. I can't divide it by 3, divide it by 4, you get 10. 4 and 10 are both not perfect cubes. Divide it by 5, 40 divided by 5, I get 8. Bingo, 8 is a perfect cube. So 40, I'm going to rewrite as 8 times 5, because 8 is a perfect cube. And then back to the variable part, 7 is not divisible by 3, so you have to think two different ways, differently for the coefficient than you do for the variable. The variable is actually easier, isn't it? 7 is not divisible by 3, but 6 is. So we'll factor that into x to the 6th, cube root x to the 1st. And now this is going to change, and this is going to change, and these two will stay under the radical sign. Cube root of 8 is exactly 2. Cube root of x to the 6th will be x to the 6 divided by 3 is 2. And now I get my cube root radical sign here for whatever got left behind, a 5 and a x to the 1st. So this is my simplified version for that. 2x squared cube root 5x. I'm going to slide over to the right. Now we got 4 different things here. Wow. Well, 24. What happens with 24? If you divide 24 by 2, you get 12. Divide 24 by 3, you get 8. 8 shows up a lot in these, because the numbers get just too darn big. Now for the variables, a to the 3rd, that's divisible by 3, so we'll just leave that sit for the moment. 10 needs to be broken down. So we're going to change that b to the 10th into b to the 9th, b to the 1st, and finally for the c term, c to the 4th, we'll rewrite that c to the 3rd, c. Now, this changes, that stays, that changes, that changes, that stays, that changes, that stays. So cube root of 8 is 2. Cube root of a to the 3rd is a to the 3 divided by 3, makes that a to the 1. Cube root of b to the 9th is b to the 9 divided by 3 is 3. And cube root of c to the 3rd is c. And what's still living under the radical? A 3, a b, and a c. 3, b, c. Okay, so that's the simplified version of that. Now for another type of exercise in this chapter, we don't want to have a fraction. There's these different conditions for radical to be considered simplified. We're in the 4th one now, and it state the others specifically, but you can go back and read them. You're not allowed to have a fraction in the radicand. No. You could jump in and start trying to simplify each of these individually, but if you just simplify the fraction first, remember, in this situation we subtract exponents, and the bigger exponent is on the top, so we get just x to the square root of x to the 17, take away 3 is 14. And 14 is divisible by the invisible 2. So the final answer here is just x to the 7th power. That wasn't too bad. Go over here. Again, before you start trying to factor the 4 and the 256, just simplify the fraction. We can simplify this fraction by dividing the top and bottom by 4. 4 divided by 4 is 1, and 256 divided by 4 is 64. And then we can think like this. This is the cube root of 1 over the cube root of 64. And the cube root of 1 is 1, and the cube root of 64 is 4. Isn't that handy? All right. Zoom in a little. Again, reduce the fraction first. This will be 5th root of x to the 6th divided by x to the 1st is x to the 5th. And 5 divided by 5, you get x to the 1st. So this fancy looking thing turns out to be just plain old x. Okay? And then last thing on page 3, again, reduce this, or 32 divided by 2 is 16. So it's 4th root of 16, which is exactly 2, because 2 to the 4th is 16. Okay. Oh, I'm sorry, I went off the screen there. 4th root of 16 is exactly 2, because 2 to the 4th is 16. That's the end of page 3.